Hi, I'm Aimee LeBrun from the CCDC. Welcome to this video on how to measure distances, angles and torsions in Mercury. Distances, angles and torsions can be measured using Mercury. This provides information on the geometry of a structure. In this video, we will illustrate how to measure distances, angles and torsions for bonded atoms, as well as for intermolecular interactions such as hydrogen bonds. To begin, open Mercury. Next, load the structure ABAHUI in the Structure Navigator. You may select the structure of your choice if you wish to try this functionality out on another. Alternatively, your own structure can be inputted via the File menu. For easier selection of the atoms involved in the measurements, we turn on Labels. For clarity, ensure labels are added to your non-hydrogen atoms. Now that labels are displayed, we can move to measurements. First, we will look at how to measure distances between atoms. Next to Picking Mode, select Measure Distances in the drop-down menu. Click on the two atoms you wish to measure the distance between. In this example, we will measure the distance between N1 and N2. The distance will appear and it is 1.303 angstroms. To clear any measurements, select Clear Measurements. Next, we will look at how to measure angles between atoms. Next to Picking Mode, select Measure Angles from the drop-down menu. To measure an angle, three atoms must be selected. So, I will select C6, N1 and N2 to find the angle between them. The angle will appear, and in this case, the angle measures at 119.44 degrees. Note that the order of the atom's selection is important. Again, clear your measurements with the Clear Measurements button. The final tool we will look at is measuring torsions. Again, next to Picking Mode, select Measure Torsions. To measure a torsional angle, four atoms must be selected. I will select C6, N1, N2 and C7 to measure the torsion. The torsion measures at minus 179.23 degrees. Also, in this case, note that the order of the atom selection is important. To view your measurement, click on More Info and you will see the options Distances List, Angles List and Torsions List. Click on Torsions List. A window will appear with the measurements you took. This can be saved as a document by selecting the Save button. Select a file destination, a file name and format, and click Save again. Measured angles and distances can also be viewed and saved in this window by clicking the buttons on the side. These are empty as I previously cleared these measurements. Clear your measurements. We will now look at measuring hydrogen bonds. Show labels for all atoms. Display hydrogen bonds by selecting the H bond box in the Display Options toolbar at the bottom of the Mercury interface. There is an intramolecular hydrogen bond between O3 and H16. To measure the bond distance, select again Measure Distances and click on these atoms. The hydrogen bond length is 1.868 angstroms. To measure the angle, select again Measure Angles and click on O3, H16 and N1. The angle value is 135.28 degrees. Next, look at measuring intermolecular hydrogen bonds. Load the structure HXACAN in the Structure Navigator. Make sure the hydrogen bonds are turned on, and you may click on any of the hanging atoms to reveal the full molecule. Hydrogen bonds can occur between molecules as shown. A hydrogen bond forms between H6 of one molecule and O1 of another molecule. The bond can be measured by selecting Measure Distances and clicking on both atoms. The hydrogen bond length is 2.213 angstroms. Clear the measurements. The angle between the N1, H6 and O1 can be measured. Select Measure Angles and click on the three atoms in the correct order. The angle is 159.03 degrees. You can also measure distances, angles and torsions for atoms that are involved in other types of intermolecular interactions and other non-bonded atoms. You can try some measurements on your own structures or practice with the ref codes seen on the screen. For some practice on measuring hydrogen bonds, try this example. Thank you for watching this video. Don't forget to subscribe to our YouTube channel.